Addition of forces. First, when forces are on the same direction, then the resultant net or total force F equal to F1 plus F2. Second, if the forces are on opposite directions, then the resultant force F will be equal to F1 minus F2. Third, if the forces are perpendicular to each other, then the resultant force F will be equal to the square root of F1 plus square of F2. Example 1. Case 1. The resultant force F equal to F1 plus F2 equal to 8 plus 6 equal to 14 Newton. For case 2, the resultant force is equal to F1 minus F2, which is equal to 8 minus 6 equal to 2 Newton. For case 3, the resultant force would be F equal to square root of F1 square plus F2 square equal to square root of 8 plus square of 6 equal to 10 Newton. Notice that the resultant force must lie between F1 plus F2 and F1 minus F2. Example 2. Part A. The maximum resultant force F maximum equal to 1 plus 2 plus 3 equal to 6 Newton, while the minimum resultant force is F minimum equal to 3 minus 2 minus 1 equal to 0 Newton. Part B. Since the resultant force lies between 6 newtons and 0 newtons, for part 1, the resultant force 7 Newton is impossible. However, for part 2 and part 3, the resultant force for 4.5 Newton and 1 Newton is possible, since these two forces lies between 0 and 6. Resolution of forces. Consider a force F acting at a point P at an angle theta to the horizontal. We have the horizontal components of the force is F x equal to F cosine theta, and the vertical components of the force is F y. Example 3. The horizontal components of the force P at P is F x equal to 20 cosine 30 degree, which is equal to 10 root 3 Newton, and the vertical component of the force F y is equal to 20 sine 30 degree, which is equal to 10 Newton. Types of forces. First is gravitational force. Every object is attracted by the Earth. This attractive force is called gravitational force. 重力. The symbol is Fg. Fg is equal to the product of the mass of the body and the acceleration due to gravity at the point. If we consider the Earth as a whole, gravitational force on the man is directed towards the center of the Earth. If we consider a horizontal surface, the gravitational force on the man standing on the surface is perpendicular to the surface. The gravitational force on a man above the surface is also perpendicular to the surface and pointing downward. Note that Fg equal to mg. Note that weight is equivalent to gravitational force. That means these two terms are identical. Also, the weight of a body, W, depends on the acceleration due to gravity on the surface, G. What are the differences between mass and weight? Mass, m, weight, W. First, mass is a measure of the quantity of matters inside the body. Weight is a measure of the gravitational force on a body. Second, mass is a scalar quantity, that is, it only has magnitude. But weight is a vector quantity, which means that it has both magnitude and directions. Third, the unit of mass is kg or gram, and the unit of weight is Newton. Fourth, the mass of a body is independent of the position of the body. However, the weight of a body depends on the position where it is. Example 4. The weight of the man on the earth, W, equal to mg, equal to 80 times 9.81, which is equal to 785 Newton. For part B, when he is on the moon, the mass of the body is the same, which is 80 kg, but the weight is different from that on Earth because weight equal to mg, and the accelerations due to gravity on the moon's surface is only 1/6 of that on the Earth's surface. Therefore, the weight on the moon's surface equal to 80 times 1/6 times 9.81, which is equal to 131 Newton. The second kind of force is called tension. When a string is stretched, the force in the string is called tension, 張力. The symbol for tension is T. Example 5. In each of the cases below, draw the tension in each mass. For the first case, if the body is moving to the right, the tension on the string is T acting on the mass M. In the next figure, if both masses are connected by string and they are pulled towards the right, the tension of the string on M2 is T1, and the tension of the string on mass M1 would be T1 and T2. In the next case, a mass M is connected by a string which is hung over the ceiling. The tension of the strings acting on the mass M is T. In the next case, a mass M is pulled by a string up an inclined plane. Then the tension of the string on the mass M would be T. In the next case, if a string is pulled by the hands onto two sides, then the tensions on the left hand is T, and the tension acting on the right hand is against T. Now, if the tension is connected to a spring balance as shown, and the strings on both sides is being pulled by the hand, if the spring balance reading is 10 Newton, that means the tensions acting on the left hand is equal to 10 Newton, and the tension of the string acting to the right hand is also equal to 10 Newton. The third kind of force is friction, 阻力. Frictional force, F, does not exist when a body is moving on a smooth surface. However, frictional force, F, exists when the body is moving on a rough surface. Frictional force is on the contact surface in a direction opposite to the direction of motion. Frictional force exists when a body is at rest or stationary on a rough inclined plane. The direction of friction is uphill. Example 6. A block on a rough horizontal surface is pushed by a horizontal force F. Let's complete the table. If the pilot force is 0 and the block remains stationary, then the frictional force acting on the block is equal to 0 Newton. However, if a pilot force is 1 Newton and the block remains stationary, then frictional force is also 1 Newton. Similarly, if the pilot force is 2.5 Newton and at this stage the block starts to move, that means the frictional force is still equal to 2.5 Newton. However, if the force is increased to 3 Newton and the block will moving to the right, in this case, the frictional force will remain at its maximum value, which is equal to 2.5 Newtons only. Similarly, if the apparent force is increased to 5 Newton and the block is also moving to the right, and the frictional force will still remain at 2.5 Newtons only. From the above observation, we noticed that frictional force F due to a rough surface has a maximum value. The last kind of forces we are going to study is normal reaction, R. Normal reaction or reaction is the force exerted on a body by the contact surface. Note that normal reaction is perpendicular to the contact surface. Also, normal reaction is equivalent to supporting force. Newton's first law of motion. Newton's first law of motion states that, first, in the absence of let force, a body will remain at rest. Example 7. A smooth cardboard is put on a bottle and a cone is on the cardboard. Part A. Explain why the cone is at rest. The cone is at rest because the weight of the cone is balanced by the reaction force acting on it by the cardboard. Therefore, there is no net force acting on it. Therefore, it remains at rest. Part B. When the cardboard is pulled horizontally from the bottle, the reaction force disappears. Therefore, there is a net force which is equal to weight W acting on the cone to change its state of motion to make it fall down into the bottle. Newton's first law also states that in the absence of net force, an object will continue its state of motion Example 8. In terms of first law of motion, explain what happens to the passenger standing in a bus when the bus is braking sharply. When the bus is braking sharply, the braking force exerts on the bus only, but not on the passenger. Therefore, the passengers will move forward. When the bus is started from rest, the starting force again is also acting on the bus only, but not on the passenger. Therefore, the passenger will jerk backward, or we say the passenger will move backward. Note that the inertia of an object depends on its mass only. Greater mass means greater inertia. Also, if net force equal to 0, the change in velocity of a body will be equal to 0, implying that the body is either at rest or moving at uniform velocity.